Hello, Teak Tigers. We are ready for the last day of representing whole numbers, which is lesson 5 of concept unit 1. We're going to start off with a math stretch. And this one is it's kind of fun to solve, I think, because it's kind of like a brain teaser. You have to solve a part to get another. It's really fun. I love it. So let's look at it. Abby, Carter, Scott, and Tracy reward their dog with treats each time one of their dogs does a trick. Each child began with 10 treats. Abby's dog did 5 tricks. Carter's dog did 2 less tricks than Scott's dog. Scott's dog did 1 more trick than Abby's dog. Tracy's dog did 3 more tricks than Carter's dog. How many treats did each owner have left? So you're going to pause your video at this point and work this in your journal. Come back when you have finished working the problem out. I promise there's a solution to it. So pause your videos and work the problem. Okay, so now that you've come up with an answer, let's see how you did. This is how I worked it out. I listed the children's names, Abby, Carter, Scott, and Tracy. And then it told me I have to find the tricks first before I can find out how many treats were left over. So if I read the first thing, it says that, so my first line underneath the names is for the tricks. It tells me that Abby's dog did 5 tricks. 5 tricks. And then it says that Carter's dog did 2 tricks less than Scott's dog. Well, I don't know how many tricks Scott's dog did yet, so I can't solve Carter at this moment. But I can say that it's Scott's tricks minus 2. Scott's dog did 1 more trick than Abby's dog. So that's 1 more than Abby, 1 plus Abby. And then Tracy's dog did 3 more tricks than Carter's dog, 3 plus Carter's dog. So that will, what I've set up here is kind of like equations. I can plug in the numbers that I know and start solving the problems. So we know that Abby's dog did 5 because it just told us straight up 5 tricks. So I've got tricks again because this first line was how am I going to find out how many tricks, and this line is for how many tricks they did. So the first thing I came to was that Carter's dog did 2 less tricks than Scott's dog. Well, I really don't know Scott's dog yet, even though I can see it over here. But I know that I don't know Scott's dog, so I skipped over this one first and went to Scott's dog because that was the next thing, because I needed to know Scott's before I could find Carter's. Scott's dog did 1 more trick than Abby's dog. So 1 trick more than Abby's 5 tricks, so 1 plus 5 equals 6. So now I know how many tricks Scott's dog did. So I can go back and solve Carter's now. I know that Carter's dog did 6, Carter's was Scott's dog, how many Scott's dogs did, minus 2. So Scott's dog did 6. So I did 6 for Scott minus the 2 equals 4. So Carter's dog did 4 tricks. So now I know Abby, I know Carter, and I know Scott. So now the last thing to figure out is how many Tracy's dog did. So Tracy's dog did 3 more than Carter's dog, 3 plus Carter. So that would be 3 plus how many Carter's dog did. And Carter's dog did 4 tricks. So 3 plus 4 equals to 7. Okay, so that's not the answer to the problem yet. That tells us how many tricks each dog did, but that doesn't tell me how many treats each dog owner had left. Okay, so to figure that out, that's my next line for treats left over. I have to start with the 10 treats that they had. And I'm going to subtract the tricks because each trick was worth 1 treat. So 10 minus 5, 10 treats minus 5 tricks means that Abby has 5 left. Carter's dog, or Carter has, he started with 10 treats. His dog did 4 tricks, so he has 6 treats left. Scott's dog, he started with 10 treats. Scott's dog did 6 tricks, so he has 4 treats left. And then Tracy's dog, of course, she started with 10, the same as everyone else, minus the 7 tricks that Tracy's dog did, left her with 3 treats. So my final answer is Abby has 5 treats left, Carter has 6 treats left, Scott has 4 treats left, and Tracy has 3 treats left. So I hope you found that fun, and I hope you learned something from it. We'll do more of those later. Okay, so let's go ahead and launch the lesson. So let's start with task A. It says, what is the difference in the value of the 8 and the number below? And justify your response. So the 8 in this number here, and this entire number has 2 8s. They're underlined for you. So we want to know the difference between the value of this 8 and the value of this 8. So you're going to pause your computer and work this in your math journal. Come back to the video when you have an answer and compare it with mine. Okay, so what we did here was the 8. Let's go ahead and read the number first. Okay, so we have over here, we know that our numbers are separated by units, okay, or by commas, and the units by the commas, the period, sorry. This period of 983, this last one, the last 3 digits are always the units period, okay? Then if it has digits in front of it, the next set of 3 digits is the thousands unit. And then if we move over again, we have this set of 3 numbers, and it's the millions unit. So at the comma, I'm going to say the name of the unit. Sorry, I keep saying unit. The name of the period. We're going to say the name of the period after the number. So we read it in chunks of 3, and it makes it really easy. So I know that this, and if I need to use a place value chart, I know I can do that because I can pull it up from my toolkit, or I can pull it up from yesterday's lesson. So I know that this is the units period, the thousands period, and the millions period. So I'm going to read this group of numbers, and I'm going to stick the last name of millions on it. Read this group of numbers, put the last name of thousands on it, and then I just simply read this part. So 485,367,983. Okay, so that's how you would read that number. That's a big number. It's the biggest one you've read so far. So let's look at the 8. And this 8, we know it's in the millions period. So this column would be the 1 millions. This would be the 10 millions, and this would be 100 millions. So if I have an 8 in the 10 millions column, what number do I have? That 8 is really representing the number 80 million, okay? 80 million. I have 80, and then it's just million because I don't have anything in the thousands, I don't have anything in the units. So then I look over here to the next 8, and I see that it is in the tens column. It's in the units period, but in the tens column. I know an 8 in the tens column is 80. So I have 80 million, and I have 80. And I want to know the difference between the two. I want to know what the what the difference is between the two of them. And so that usually, not always, but usually means if you're looking for the difference in something, you're looking to compare them and you are looking to subtract. Okay, it's comparison subtraction. So now this is a hard number to subtract because there are so many zeros and we have a whole number here. So we have to subtract across a lot of zeros. So, oops, sorry about that. Okay, so I hope you can see this. All right, so I have 0 minus 0, and that gives me 0. 0 minus 8 gives me, oh wait, I can't take 8 from 0, can I? No, I can't. So I'm going to have to borrow. So I'm going to borrow so I can make this. I'm going to have to borrow something. So I'm going to go across. I can't borrow from there. That's because there's nothing there. Can't borrow here, can't borrow here, can't borrow here, can't borrow here. Oh my goodness. Finally, there is a number. There's a column that I can borrow from. Okay. So I'm going to make this 8 a 7. So because I'm borrowing to give it to this one. Okay. So I'm borrowing to give to this one and to this one, this one, this one, and this one. Now, the easy way to think of this is the first time that you have to regroup in subtraction with zeros. The first time you do it, that 0 becomes a 10. Then all the other zeros that you have to subtract, there's all these zeros. So every one of those is going to be a 9 because I have to borrow from something every time. Basically, this 0, I'm borrowing from this, and this is going to become a 10. And then I'm going to have to borrow for this one, so I take one away, and so that's 9. So short story sweet. First time is 10. Everything else are 9s until you can finally borrow. You take one away from that one, from that whole number, and you can finally do the subtraction. So I know 0 minus 0 is 0. 10 minus 8 is 2. 9 minus 0 is 9. 9 minus 0, because there's nothing down here. 9 minus 0 is 0. 9 minus 0 is 0. 9 minus 0 is, oh, sorry. Oh, Lord. Okay, so now I'm going to subtract. 0 minus 0 is 0. 0 minus 8, oh, wait a minute. I can't do that, can I? So I have to borrow. And I can't borrow from this one. I can't borrow from this one. There's nothing there, nothing there, nothing there. So I have to finally borrow it from the last position. So that 8 becomes a 7. This 0 becomes a 10, but I'm going to take one from it, and it's going to be a 9. And then all the others are 9s, and this one is a 10. So I'm kind of giving you the short version of this. Basically, the first time you have to borrow with zeros, that first 0 becomes a 10. And then every other 0 in a row after it, every 0 in a row after it becomes a 9 until you finally get to a number that you can borrow from. And that number is, that 8 I can borrow from. So I'm going to take that 8, cross it out, and make it a 7. So now I have 79,999,910. So now I can do the rest of my subtraction. 0 minus 0 is 0. 10 minus 8 is 2. 9 minus 0 is 9. 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 And 7 minus 0 is 7. So my answer is 79,999,920. Very good. Okay, so now it's time to look at the work that I'm going to want you to do for me today. This assignment is called What is the Value? You're going to place one digit card in each of the place value positions on the place value chart to represent a multi-digit number. Well, actually, we're not going to use digit cards because you don't have the copy of it to cut them out. So what you're going to do, and actually yours is going to have 3 columns, and you're going to make 3 numbers, like 3 long numbers, not just 3 digits, but you're going to fill this place value chart up with digits to make big numbers. And then you're going to record the created number and represent the value of the number using expanded notation. So that number that you wrote up here, you're going to put it into expanded notation. And remember, we looked at that yesterday, so if you need to review that, you can. Remember, we take each place times the value of the place value plus the next digit plus its place value plus the next digit plus its place value. Now this is interesting because I go from hundreds to ones. That's because there's a 0 there that's kind of a placeholder. We don't have any tens, so I don't need to show the tens. But if I'm writing this number back, I need to make sure that I have 0 in the tens column because that will change the number I'm actually writing. So then, once you write this number in expanded notation, you're going to write the number 2 more times, or write 2 more numbers. I'm sorry, you're going to write 2 more numbers into this place value chart, and then you're going to write those next 2 numbers you wrote into expanded notation. So that is the assignment, and you are going to turn that in. You're going to work it in Kami. And like I said, this place value chart on your actual assignment has 3 rows for you to do the 3 different numbers. Okay, so like I said earlier, we do have a cool down lesson for, or cool down for this lesson. A cool down kind of lets us see where you're at with this objective. So the questions, and you're going to do this in Kami and turn it in. How could the number shown below be represented in word form? So you're going to, they've given you this number that's an expanded notation, and you're going to have to put it in word form. Here's a hint. I would put it in standard form first. I know it's an extra step, but trust me, it will be very beneficial for you. I would use my place value chart as well. And I would put the digits where they belong in the place value chart, and then write my number in standard form, and then read that number and write down exactly what you read. If you write the words for what you actually read, then you'll get this right, okay? And remember, on the place value chart that was in yesterday's lesson, you can go back to it, and yesterday's lesson, it had the words, it had the number words, and it had the place value chart. You also have a copy of this that was included in your packet that was sent home before school started. So number 2 says, in 2008, the total number of cell phone users in Indonesia was about 140,578,000. Which expression has the same value as 140,578,000? So this number is given to you in standard form, and you're going to break it into expanded form. Okay, remember, expanded form is kind of similar to expanded notation, but expanded notation uses multiplication signs, and expanded form uses only the plus signs, and it gives the value of the digit, not just the value of the place. Expanded notation gives you the digit plus the value of the place. Expanded form gives you the value of the digit in that place. Okay, so that is what you need to accomplish for today. And I hope you do well with it and have a great day. Part 2 is coming up next, where we get into the platform.